Now we have another question under physics. It's actually under Ohm's law, right? We have to calculate the resistivities of a wire of length 2 meter and cross-sectional area of 0.004 centimeter square if its resistance is 3 ohms. When something like this in exam, don't need to be panicked. Just try the what? Write the value down. We have the length is 2 meter. It didn't take less than 1 minute to achieve with it. And cross-sectional area, the area is given as 0.004 centimeter square. If its resistance is 3 ohms, resistance is 3 ohms, and we have to calculate for what? Resistivities. First, after this word now, we have to check the values first. The values, we have the length in meter here, we also is what? In centimeter square. That shows that we need to convert this to what? To meter square instead of centimeter square, so that we have the same units with the first length that we have here. And how can we do that now? Now bring it out as what? As 0.004 centimeter square, right? Then from centimeter square to meter is what? Is ordinary 100, right? Which will give us, let's say that we put it in standard form, for example. Standard form, this one will give us 4 times 10 to the power of what? I mean, zero you have there? 3, Abby? That's minus 3 over, what one is just what? 100, that is what? 10 to the power of what? 2 to give us 100. When it's 2 is going up now, it changed to what? It changed to minus, right? Isn't it? Because it's crossing what? This all over here, change to minus, right? So now means now we're going to have the final one as what? As 4 times 10 to the power of minus 3, then minus 2. We should have everything as what? As 4 times 10 to the power of what? Minus 5 what? Meter square. So now we've converted to what now? To meter square now, right? Now let's now come back to what we have to calculate. We have to calculate the resistivities of what? Of a wire. And what formula are we going to apply? Don't forget the formula. If you don't know, just write it down somewhere. So we have resistance equals to resistivities, length, and cross-sectional what? Area. That's formula to what? To apply. So I'll write it down. Now resistance there is what now? Is actually 3 ohms. So we have put 3 here equals to, what is our resistivities? That is unknown. Then time, what is our length? The length is what? Is 2 meter here. Then over, what is the area? The area has become what now? 4 times 10 to the power of minus what? Minus 5. So now, mathematically, when you cross multiply in this case now, because you have the constant between the fraction, cross multiply here, so we have 2p equals to, this time this 4 give us 12 times 10 to the power of minus 5, right? Now to make this p the subject, you have to equate this 2 over 2 here, over 2, this cancel out now. So we have resistivities equals to, when I divide this 2 by this 12, that will give us 6, so we have only 6 in this place, right? So therefore we have resistivities equals to 6 times 10 to the power of what? Minus 5. Now what's needed for what? For resistivities? Just what? Ohms per meter. So I hope you find this class very interesting, right? So don't forget to like the video, share, and comment. Thank you.